Hi everyone, in today's lesson we're going to review midpoint Riemann sums. Our goal will be to calculate the estimated area bounded by the x-axis and the curve using midpoint Riemann sums. We'll use integration to find the exact area, and then again we'll use the percent error to find the difference between the actual and the estimated areas. So we have a new problem here. Use the midpoint Riemann sums with two rectangles over this interval with this function. So take a minute and sketch the picture with the table and then hit resume when you're ready for the answer. Okay, this is what I got. Okay, so it says here that I want two rectangles over the interval. So again, you can clearly see that you have 1, 2, 3, 4 spaces. So if I want two rectangles, I would just have to do every two. But we can use the formula. So again, for delta x, to find the width, we would do b minus a over n, where n is the number of rectangles. A is 0 and b is 4. So 4 minus 0 over 2 would give us a width of 2. And we want to do midpoints. So the midpoint is a little interesting. It's a little tricky. If this is my width of 2, we have to take this width and go to the middle of that width. So the first height is actually going to be at 1. This is the middle of this first interval from 0 to 2. So that's your height, and we go over and make our middle height for the rectangle. Then from 2 to 4 is the other rectangle. We're going to use the middle of that interval, which is 3. So we go up to the curve and we go over, and that is our second rectangle. So again, if we want to calculate the area, this width is still 2. This width here is still 2. We have to find our heights. So here, this point right here is 3, 27. And this point right here is 1, 1. So my height over here is 27, and my height over here is 1. So to find the area, we're going to do the base times the height. So the base is 2, or the width is 2 with a height of 1. That's this rectangle over here. The next one is going to be a base of 2 and a height of 27. So 2 and then 27. So 2 times 1 is 2. 27 times 2 is 54. So just add those together and you get a combined total area of 56 units squared. Now, to figure out what the exact area is, let's type into our definite integral from the interval from 0 to 4 of x to the third dx. So take a minute, type that into the calculator, and hit resume when you're ready for the answer. Okay, so I got 64, so 64 units squared. All right, so I'd actually like to now calculate that percent error. So the percent error here is our actual, which is 64, minus the measured, which is 56, over the actual, which is 64, and then times 100. So take a minute, type that into the calculator, pause the video, and then hit resume when you're ready for the answer. Okay, so I got 0.125, which if you multiply it by 100, gets you approximately 12.5% error. Now, with these questions, the midpoint ones, it's actually really hard to figure out if it's an overestimate or an underestimate because parts of it are over and then parts of it are under. So there's really no way to tell. You only will have to be able to tell if you look at the error to see how far off it is. Okay, let's try the same example, but I want to increase the number of rectangles now. So as we've been doing all week, if we increase the number of rectangles, we should be getting closer to the exact area. So take a minute and redraw your picture here and your table of values, and we're going to do the midpoint together. So pause the video and then hit resume when you're ready. Okay, so we need to first figure out our width. So I'm going to put delta x, which again is my width, and we're going to take the interval, which is a and b. So the formula is b minus a over n, where n is the number of rectangles. So b is 4, a is 0, divided by 4, which is 1. So each of our rectangles are going to have a width of 1. So that is nice, because there's 4 spaces. So to find the midpoint between 0 and 1, we would just have to go halfway, which would be 0.5. So I'm going to use that in green here, 0.5. Halfway between 1 and 2 is 1.5. Then we have 2.5 and 3.5. So what would be ideal is first let's draw the pictures and then we can get the heights. So if we're using the middle of between this interval, it's 0.5. We're going to go up to the curve and then left and right? We're going to go down. Then with the 1.5, we're going to go up to the curve and then down. And then at the 2.5, we're going to go up to the curve and down. And then at the 3.5, we're going to go up to the curve and down. So it's obvious that our widths are still 1, even though I'm actually looking for the height at 0.5 here. This entire width is always going to be 1. So this is 1, this is 1, this is 1, and this is 1. We need our heights. So the height of this rectangle is found by taking the 0.5 and finding the y value. This height over here is found by taking the 1.5 and finding the y value. This 2.5 and finding the y value. And this 3.5 and finding the y value. So if you want to do this easiest, I guess you can type into the calculator. You can hit second table set or second window, and you can adjust your change in table. So your table start should be at 0, the beginning of the interval, so the a value. And your delta in table, your change in table, should be 0.5. You want to go by 0.5s. So you can do that and then get a new table of values, but really all we care about is the 0.5, the 1.5, the 2.5, and the 3.5. So take a minute and figure all those numbers out and then hit resume when you're ready. Okay, so 0.5 was 0.125, 1.5 was 3.375, 2.5 was 15.625, and 3.5 was 42.875. So now let's use that information to find our area. So to find the area, we need our heights. So I'll start with the 3.5, which is a height of, so this one is a height of 42.875. So I could just write 42 approximately. This one's approximately 15, this one's approximately 3, and this one's approximately 1. So the width of all of these rectangles is always 1. So 1 times, and I'll start on this side. So 1 times 0.125, 1 times 3.375, 1 times 15.625, and 1 times 42.875. So take a minute, calculate what that equals, and then add them up to find the area, and then hit resume when you're ready for the answer. Okay, so adding them all up, I got about 62, or exactly 62. So this is 0.125, 3.375, 15.625, and 42.875. So 62 units squared would be our area. We don't need to redo this second integration. You kind of did it before in the first part. And that answer was about 64 units squared. So we're getting closer. Let's find that percent error. So the percent error here is the absolute value of the actual minus the measured over the actual times 100. So take a couple minutes, plug that into the calculator, pause the video, and then hit resume when you're ready for the answer. Okay, so I got 0.03125, and if you move that 2 places to the right, that's approximately 3.125%. So much better error the more rectangles you have. All right, that's it for today. If you have any questions, please let me know.